Okay, so last week we spent a lot of time talking about, not last week, 2 weeks ago. Yeah, so 2 weeks ago we spent a lot of time talking about real-time ray tracing and also the path tracing and also the rendering equation. So beside, of course, rendering the rendering pipeline or the ways or different approaches for rendering is, I would say, are super important for you to achieve a certain look. But on the other hand, we also need to consider, for example, the complexity of the models and also different approaches to show 3D contents to the user. So the first thing I'd like to introduce a little bit is about photogrammetry. So I guess many of you know this particular approach, right? So photogrammetry. So you just take a lot of pictures and then try to use computer algorithms to calculate the corresponding angles that all the pictures were taken at, right? So these are photogrammetry, and based on all this 3D information, we can reconstruct the 3D models. So the photogrammetry photogrammetry pipeline is very straightforward. So first of all, photogrammetry is the projection of 3D scenes onto a 2D plane. So basically, it's more like reverse the process to rendering, right? So for rendering, you use the camera, the virtual camera, right, to convert and also plus the rendering pipeline, no matter it's a rasterization rendering pipeline or a ray tracing pipeline, you try to convert 3D scenes to a 2D image that can be displayed on ordinary 2D displays, right? Or even in head-mounted displays, as I mentioned many times previously, we are still dealing with two-dimensional displays. So we still need to display 2D images, right? So this is about rendering. And also photography is the same thing. We use a camera system, including the lens, to capture the 3D world and then project to the camera sensor, right? And then form the 2D image. But photogrammetry is the reverse process. So it's more like we already have a lot of 2D pictures and we try to reconstruct the 3D scene. So there are different, computer vision based pipelines inspired by human perception, like structure from motion and multi-view stereo. So these are all different ways to do this photogrammetry. And if you are really interested into this, I can show you a software, and this software is called Mushroom. Not Mushroom, Mushroom. Mushroom. Yeah, so this software is an open source software, so you can download it and try to do some crazy photogrammetry reconstruction. Let me find where is the. Yeah, so basically you can download it and use it for free. So in general, you take a lot of pictures of a single object and put into this mushroom, and then it has certain pipelines for you to work at. You can do some tweaking of the parameters, and then you can generate a 3D scene. So remember, one very important thing is that you have to keep the exposure relatively even across all the images you are going to take. This is super important, okay? So sometimes you use, for example, you use your iPhone to take a lot of pictures of a 3D object and then import into Mushroom, and it may not generate a very good result. It may have a lot of noise, or sometimes the software just tells you that there is not enough information to reconstruct the 3D scene. Okay, simply because it's not because the number of pictures is not enough. It's simply because the exposures may vary a lot. So the best way to do this photogrammetry is to have a very even kind of light to your 3D object you want to reconstruct, and use professional cameras to control the exposure so that the exposure can be very even, and then you can get the optimal result. So of course, at the very first lecture of this particular subject, we talked about photogrammetry as well, and I mentioned that there are lots of meshes and also triangles will be generated through doing, photogrammetry. So rendering could be a really big problem unless you apply certain algorithms to reduce the amount of polygons. But there is a way to generate, I would say, also very immersive kind of, scenes for users. That is to use a cinematic VR. And it's basically a 360-degree video wrapped around the viewer. Okay, so I have a picture for you. So this animation tells you what is a cinematic VR. So 360 video wrapped around the head of the viewer. So this is a 3D video, a 360 video. And for true virtual reality or 3D model based rendering, we have all the 3D models, right? So like the 3D models here. So for example, all these trees are 3D models. So the user can freely navigate within the scene. So this is the process that you have already implemented, right, using Unity. So you import the 3D models, build a scene, and let the user to freely navigate within the scene, right? So this is the second approach. But for 360 video, it's different. The workflow is also different. You have to use certain cameras, like the ones Insta360 cameras, to capture the original videos in 360 format first. Okay? But it's not something magical. Okay? So you know that if I do a UV unwrapping of a sphere, so what is the optimal way to store the texture for this sphere? Without considering, for example, without losing the resolutions on any of the axes. So you do not lose resolution on the horizontal axis. You do not lose resolution on the vertical axis. What is the best way? So basically, you can store the, first of all, you can divide the sphere into two semi-spheres, okay? And then for each semi-sphere, the most efficient way to do the UV mapping is to use 1-to-1 ratio squared texture to store the information. So when you do the 360 video, it's basically, maybe I show you this picture so you can understand this. So it's basically, if you cut from the middle, like you cut it from here, and you have two frames, right? So this is the right frame, and this is the left frame. You can directly wrap these two squared images to two semi-spheres, and then you can have a very high resolution and 360 experience. So for any 360 videos you captured using cameras or other approaches, you can actually expect that the aspect ratio should be 2-to-1. 2 on the horizontal axis and 1 on the vertical axis, or 2 for the width and 1 for the height. Okay, so yeah, so this is about 360 video, and yeah, I can show you some of the videos we made in the past for a project about Hong Kong. So for example, so maybe I'll show you this. So this is the Memo Temple in Central. So yeah, remember you have to use a very high quality video, otherwise you always lose the resolution. So for 8K, then basically we have 4K for each of the semi-spheres, right? So, and also when you look at a certain angle, then basically you are again crop from the entire 8K video, right? So you have a lower resolution. Sorry, wait a minute. So I always forgot to change the default playback device from the computer. Just wait a minute. Okay, so let me play again. So you can drag this around. And of course, if you view this using the YouTube app on your phone, then you can enable the cardboard, the so-called cardboard mode, and then use a Google Cardboard to view it as a stereoscopic image.
There are 11 plaques in the temple, most of which were donated by local leaders and members of the community. The plaque Xin Wei Pu Yu, the god of martial arts protects all, was bestowed by the Qing Emperor Guangxi in 1879 in appreciation for the donations to offset effects of the severe drought in China from 1876 to 1878.
Yeah, so I think you get the idea. You can use these techniques and place the camera at different locations, and then you can, let users to travel to different points to create such kind of, free navigation kind of, experience. Yeah, so this is about cinematic VR. So any questions? Any questions? Okay. So if no questions, then let's move on. So previously, we are all only talking about the rendering of, visual stimulations, right? Artificial sensory stimulations. Still recall Laville's definition of VR, right? So of course, artificial sensory stimulations is not only about visual stimulations. So we have to consider other types of simulations. So for example, I have already showed you this particular diagram. So for the organism, it does not only perceive the rendered images and also other artificial sensory stimulations from the XR devices, XR hardware, right? Because the organism is always within the physical world, so it can also perceive things around. And in many cases, for XR, especially if you consider mixed reality, augmented reality, then basically we deliberately let the organism to perceive the real world, right? While providing some artificial sensory stimulations. So the key about the rendering of multisensory stimulations is about tracking and providing stimulations. So stimulations can be, as I mentioned, not only restricted to images, but also to, for example, audio and maybe haptic feedbacks, right? So the most important thing when you design multisensory and multimodal XR is about perception and cognition. So let me do a very quick test with you. Okay? So from the top left corner of the screen, and we go from left to right and top to bottom. Try to say, pay attention to this, try to say the color you see. Okay, so can you do it with me? The first one, red, right? Yellow, green, purple, blue. Someone said pink, right? Black, orange, I don't know, brown, maybe brown, yeah. So next one. Yeah, I can't, I'm not quite sure. Maybe I have to refer to the, yeah, maybe some kinds of, beige, I don't know. And then gray, pink, and then deep blue, right? Yeah. So it's very difficult, actually. Yeah. If you tried it, you will find that it's very difficult. Why it is like so? Because perception and cognition, I would say, are dramatically different in many cases. Okay. So, for example, when we talk about perception, we are basically talking about how the sensory stimulations reach our sensory receptors. Okay, so this is very important. So if you are talking about, for example, images, then basically we are talking about how the light reaches your retina, right? So this process is about perception. But all the information you received may not be processed by your brain. So this is about cognition. So maybe your brain is so saturated with the task So you do not have the capability, necessary cognitive capability to process the information. Or your brain simply thinks that the information is not meaningful for the current context and will automatically ignore it. Or your brain may be so adapted for this particular sensory stimulation, and then your brain chose to ignore it, right? So I used the example of the toilet, right? After you spend some time in the toilet, you are so used to the smell, and your brain just forgets about it, right? So yeah, so this is about perception and cognition. In our case, of course, for example, the first one, the first word is in red, right? So the light spectrum reaching your retina is always red, right? So there is no question, there is no doubt about this. But how about cognition? Your language is, of course, a cognitive capability of human beings, right? So you know this word, it means blue. So your brain is always fighting with the sensory stimulations. Your sensory stimulations tells you that it is red, but on the other hand, your language capability of your brain is telling you that it should be blue. So that's why this is very difficult, and sometimes people make mistakes. Okay, so this is about perception and cognition. So of course, this is a very interesting experiment for you, but what are the insights? What are the possible, contributions that are by understanding these concept, the perception and also cognition can help you understand the design of multisensory and multimodal XR. So we just enlarge this part. So we enlarge this part, and then you have this picture like this. Okay, so for the organism, of course, as I mentioned, you have to consider both perception and also cognition, right? So for example, this is about perception, right? So I should not draw on this display, otherwise it cannot be recorded. Okay, so yeah, so this is about vision, hearing, touch. So this is all about perception, right? So the most important thing when your brain start to process the sensory stimulations is interpretation. So in this step, your brain feels like the sensory stimulations are important, and I have to make sense from all these artificial sensory stimulations, right? So this is the process when we start to use our brain, use our cognitive capability to process the sensory stimulations. Of course, this is not a very high level of human cognition. So next one would be, sorry, I should not draw on this. So next would be intention, making a decision based on, for example, the intention, your attention, your self-attention, and also emotion, right? And other things that may affect your decision. And the last one, the user will then perform some actions. Okay. When we talk about actions, in many cases, especially for virtual reality systems, when we develop virtual reality systems, we always think that actions can only be some gestures, some button presses, right? But this is not all. This is not all. So more importantly, for example, speech, right? This is very important. But have you ever tried any virtual reality applications that use speech to let you interact with the VR system? Not really, right? So yeah, we have a Kai paper that is currently in the second round about using speech to manipulate 3D objects. Right? So this is about the action. So we use speech. Gesture, I guess many of you know this, right? So you have already done your VR game development. So it's mainly based on gestures. Facial expression, I guess it's even rarer, right, to find any applications that let you interact with the VR systems through facial expressions, writing, and etc. Right? So these are all possible actions that we do in real life, but we rarely do it in XR simply because we may not have the necessary senses to capture these type of interactions, or we do not have the necessary computational power to process the actions, right? Until recently, we do not have a very powerful solution for dealing with speech, right? Because speech can be quite ambiguous in many cases. And also to process speech, you have to let the computer to have certain level of intelligence. So recently, of course, we have large language models to help you to do so, right? So I think the next step for XR development with regard to this particular box would be enabling the speech kind of actions to be captured by the XR system and then provide corresponding changes to the rendered scenes. Okay, so this is about the organism. And on the other hand, we have the XR system. So for example, this corresponds to the perception system of an XR system, right? So this time is not about an organism, it's not about a human being, it's about the XR system. So the XR system has to capture users' action using its own perceptual capabilities, right? So for example, for capturing speech, we have to use microphones. For capturing gestures, we have to use cameras plus some computer vision algorithms, right? For capture writing, we can have stylus. Some people always saying that I hope my Apple Pencil can work with my Vision Pro, right? So I can draw things in the air. So yeah, this is I would say a very good idea. And if you put it into this particular diagram we are looking at here, then basically we are talking about this pair, right? Writing and stylus. So next, of course, XR system has to interpret the data. So as I mentioned, it's very easy to capture the speech, but until recently, we do not have the capability to interpret the captured speech from a human user, right? So this is about the processing of using some natural language processing models and also, of course, large language model as well. So I won't repeat that. I think many of you are very familiar with this. And then we do the computation here to decide whether the user's input or user's actions may have some impact to the artificial sensory stimulations, right? So for example, if you want to let the avatar somehow, not an avatar, it's an agent, right? So it's a computer program controlled virtual character. So you want the agent to reply to the user's speech using language as well, right? So we have to consider how to do, for example, text to speech, right? So most of the large language models we use nowadays can only accept input as text and also output as text. So when you capture the input, you have to do text to speech to text, right? And you put into the large language model to do the computation, do the interpretation, and then when you do the output, is in text again. So in order to let the agent speak, right, you have to use text to speech engines. Okay, to enable such kind of things. But of course, if it's about the manipulation of the virtual scenes, you have to consider how to do visual rendering using, traditional rasterization pipeline or ray tracing in the future, right? And also haptic rendering. So maybe the user should be able to feel the force, right? So we have to do the haptic rendering to apply the force to some haptic devices and let users to perceive the haptic rendering. So I prepared a video for you to let you better understand how the entire system, the entire XR system can give user very realistic kind of, artificial sensory stimulations. It may not as easy as it looks. So this video is about a flight simulator. It's about a flight simulator. So it's about, training pilots to fly airplanes. Okay, so some of the manipulation of the cockpit in the simulator may not be that intuitive to understand. Okay, so let's have a look and see how this ultimate kind of XR system can provide users with artificial sensory stimulations, especially with regard to different types
In
of forces.
2001, the pilots of an F-18 taking off from a US Navy aircraft carrier did something that very few people would see coming. Immediately after being catapulted during a dark night with low clouds, the pilot mysteriously pushed the nose of the aircraft down and descended into the ocean. And to figure out why, today we're going to talk about this, the Delft University of Technology's Simona Research Simulator. This entire machine has one purpose, and that is to trick your brain into feeling like it's flying a real aircraft. Located in the city of Delft in the Netherlands, the simulator uses 3 projectors to generate an image on this dome, showing the pilots a virtual view from the cockpit. The entire cabin is supported by 6 hydraulic actuators, which are used to move the simulator in all 6 dimensions, 3 translations and 3 rotations. But how do the simulator's movements correspond to the actual movements of the aircraft? And more importantly, what kinds of sensations do people even feel when they're flying in a plane? Because as we're about to find out, the goal of the simulator is actually not to match the aircraft's movements per se. For example, it's entirely possible for the pilot to be flying straight and level, but looking at the simulator.
So just pay attention to this explanation. Okay, so for example, when the airplane is turning to the left, you would suppose that the simulator should also rotate to the left, right? But in reality, it is not like so. Okay, so let's have a look and understand why it is so.
From the outside, you might see the platform pitching up or down, which is not what you'd initially expect. But before we get into these seeming paradoxes, it's worth talking about why researchers spend so much time and effort on these things in the first place. Since almost every day, Simona is being used by the TU Delft Faculty of Aerospace Engineering to learn about how pilots control and interact with aircraft. One of the areas of our research focuses on motion cueing, which is about figuring out how to optimally fool the perceptions of pilots by manipulating their senses. For this, it's useful to think about humans having inputs and outputs. For example, during research, pilot behavior is often modeled with something called the black box method. This is where we imagine the human operator to be some unknown algorithm that takes a set of inputs from the environment, things like instruments, the view of the runway, and even sounds, for example. If we imagine humans as an algorithm, then one of our most important inputs comes from our vestibular system or inner ear, which can sense things like angular acceleration. Our inner ear is not only known to play a significant role in our sense of balance, but can also drastically affect pilots' behavior, and can even cause disorientation in certain situations. Another important input to our human algorithm is, weirdly enough, your seat. Or more specifically, the forces between your body and the chair that's supporting you. Let's start with rotation in pitch, roll, and yaw. As a first try, let's just move the platform to match the orientation of the aircraft. So for example, if you're making a turn to the left, let's just try rotating the platform to match the roll angle.
So this is very close to our first look into this problem, right? So I guess if without knowing any background knowledge, you should assume that the simulator's movement should match with the movement of the airplane, right? But this is the incorrect way, okay? This is the incorrect way. It may sound a little bit counterintuitive, but you will hear the explanation later.
Of the plane. Although this seems logical, rather quickly you'd find that this method has some problems. If you've ever been in a normal turn in a real aircraft, you may have noticed that, paradoxically, it never really feels like you're being tilted at an angle, even if the aircraft is being rolled by as much as 30 degrees. This is similar to how you need to lean your bike towards the inside of the turn when you're cycling at a certain speed. The faster the bike travels, or the tighter the turn, the more roll you'll need to stay balanced, which is also the case in an aircraft. But if we look at our simulator, you'll notice that this doesn't apply, since the platform isn't actually traveling anywhere. As a result, if we move the simulator to match the roll angle of the plane, it would be like tilting a bike that's standing still. Due to gravity, the bike would of course fall over, and in our simulator, this means that people will feel an unrealistic side force as a consequence of the simulator's roll. So now we've established that if we're in a coordinated turn with a constant roll angle, then the simulator must stay level, which is great. But what about when we enter and exit a turn? If the roll angle is changing over time, then the rate at which this angle changes is called the roll rate. This is important to know because your inner ear can sense when the roll rate itself changes.
So this roll rate, you can treat it as the acceleration of the rolling. Okay, so when you change the rolling, then basically you have a very high rolling rate. Okay, so this is very important to understand. So it's very straightforward, right? So if you sit in a, for example, on a very high speed train, right? So when you won't feel it when the train is just moving at a constant speed, right? So you can only feel it when the train is going to stop or try to accelerate, right? So this happens on just the one axis. So you can treat it, for example, as the z-axis in unity, right? This is about acceleration and deceleration. But for airplanes, it also contains the rotation, right? It's not only about acceleration or deceleration, it's about rotation. So when you do this rotation, the very key information is to care about how the roll will be changed. So if you are doing, for example, a left turn, then basically because the turn is constant, right? So it's like you are moving on a train that goes, at a constant speed. You won't feel the force. You won't feel the force, okay? But when the turn ends, you try to level off the wings, then there is a change to the rolling, right? So the change of the rolling is a very important thing. So it's a change of the rotation. So when we talk about acceleration, then basically by default, we assume that is about the change of the speed, right? But here we have to consider the change of the rotation. Okay, so this is a very important concept.
So, as it turns out, we do actually need the simulator to roll. But we can't do this too much or for too long, because otherwise the pilots will start to feel unrealistic side forces due to gravity. To solve this problem, engineers use an algorithm called a washout filter, which links the dynamics of the aircraft to the roll angle of the simulator platform. To see this filter in action, on the left-hand side of the screen, you can see the pilot's view of the aircraft.
Just to pay attention to this comparison, okay? So remember, when the roll is fixed, we are turning at a fixed roll, then basically people should not feel the force, right? If people cannot feel the force, then basically we have to level off the simulator, but not the airplane. The airplane is still in a roll, right? So just to pay attention to this. So for example, if the airplane keeps flying like this, we should level off the simulator, right? So let's have a look and see what happens.
And on the right-hand side, you can see the effect of the washout filter and how it's controlling the tilt of the platform.
As you can see, it's constantly rolling to the left, right? It's turning to the left. So the cockpit of the simulator is leveled off, right?
Based on the movement of the aircraft. Notice how the roll rate starts and then stops again. Every time the roll rate changes, the platform quickly tilts in the direction of that change. And if I add the graphs down below, you can see very clearly how changes in roll rate on the left are activating the roll angle of the platform on the right. These dynamics are exactly what's going to trigger your vestibular system. But the really clever part of the washout filter lies in the fact that as soon as the roll rates calm down, then the platform will always tend to move back to neutral or zero roll. This is called washing out the signal, and it makes sure that we never tilt the platform for too long. And as you might have guessed, it's also exactly what we need to stop the side forces that we've been struggling with.
Okay, so I just mentioned about acceleration and deceleration, right? So this time is about it's not about rotation; it's about translation. Okay, so let's have a look at what the cockpit, the simulator's cockpit should behave in different situations.
By also applying washout filters to the pitch and yaw axes, we've now got a solution for the aircraft's rotational movement. But rotations aren't the only type of movement that the platform is capable of dealing with. Something we haven't yet talked about are the forces that the pilot feels due to acceleration and gravity. And for this, we need to talk about a concept called specific force. An easy example is to consider what the pilot would feel when the aircraft is in a climb with a high pitch angle at a constant speed. Because of the pitch angle, a portion of gravity will be pulling backwards relative to the plane. In turn, the pilot will feel the forward reaction force of their seat as it supports their body. To get the pilot to feel this force in the simulator, we can simply pitch the platform up, which will also cause a forward reaction force in the same way that the real plane does. This simple example seems to suggest that humans can sense components of gravity, or at least under certain circumstances. And although this approach is definitely heading in the right direction, we haven't yet covered the full picture. Let's take a look at what happens if we're flying straight and level, but this time with increasing speed, which is to say a certain amount of acceleration. First of all, notice how throughout the maneuver, gravity will be pointing straight down, which means that it won't contribute to any horizontal forces. During the acceleration, you'll feel as if you're being pushed into your chair, which is especially noticeable during takeoff.
So I just pause a minute and ask you before continue it. So in this case, the plane is leveled off, but it's accelerating. Okay, so how we should manipulate the virtual cockpit, the simulator's cockpit, in order to create such kind of feel. Sorry? Use gravity. How to do it? Pitch up. Okay. So why it is like so? Yeah, because the acceleration will actually use the chair to push you, right? So in that case, we just tilt it up and let the chair to push your back, right? So we can then simulate this. So let's continue the video.
But note that what you're actually feeling is the chair pushing you forward as it accelerates the mass of your body, which is trying to resist this movement due to inertia. So to get the pilot to experience this force, we would have to tilt the simulator in exactly the same way as we did in the gravity situation.
Right, so this is what the gentleman said.
But keep in mind that even though the platform is pitching up, the visual information on the inside dome gives pilots the feeling that they're flying straight and level, since this is the only visual information that they have.
This is also very tricky, right? Although you tilt the virtual cockpit up, but you still give the point of view that is horizontal to the actual horizon of the Earth, right? So this is a very interesting trick to use.
This creates the illusion that the aircraft is accelerating straight ahead, which to the pilots is not only believable, but almost impossible to resist, since all of their sensory organs are giving them a consistent illusion. So even if we choose to think about gravity and acceleration as two separate phenomena, it's crucial to realize that without the context provided by your eyes, gravity and acceleration are experienced as the same sensation. That also explains why we tilt the simulator in exactly the same way in both cases. A common misunderstanding about motion systems is that humans can feel either gravity or acceleration. In reality, this isn't entirely true, because even though your brain may interpret the force of your seat as acceleration or gravity, the only thing that pilots can truly feel is the force of the chair itself. This reaction force is what is meant by the term specific force. The formula to
Okay, so I will stop the video here. I have already uploaded the video to Blackboard. So if you are interested in this and also the follow-up explanations, you can go and check it out. But I just want to emphasize this a little bit. So you saw the very fancy platform, right? So this is a 60-degree of platform, motion platform that allows translation on all three axes and also rotation on all three axes. So that's why it's called a 60-degree of freedom motion platform. It's not that expensive. You can buy a very good one that only costs like 5 to 6 digit. We are talking about around maybe 100,000 Hong Kong dollars. You can buy a very decent one. Okay, but even you have this, you have a head-mounted display. It's not, all you need to create such illusion, right? You still need to very carefully design the software in order to create such kind of illusion, right? If you don't know, and you use a very intuitive way to program it, then basically the illusion is not there, right? So when the airplane is turning, you just turn the cockpit or turn the motion platform, then people will not feel like it's the aircraft is actually turning. Okay, so again, very important to the definition of VR again. We recall that the definition of VR again. VR is not about software. It's not about hardware. It's about human experience. You purchase the corresponding hardware together and together with the corresponding software to deliver the experience, instead of just purchasing a motion platform and supposedly it will do all the things magically. It is not true, right? We have to use the software to create such experience, and the core is about human experience. Okay, so yeah, just to give you some real world application of multisensory XR. So why multisensory and multimodal XR? Our everyday experience have a multisensory nature. This is very obvious, right? So for example, when in the previous video, when the pilots are flying the airplane, they all experience multisensory inputs, right? The vibration of the airplane, the gravity, the acceleration, and also all these crazy sound and visual stimulations. Very informative, right? So this is about their daily life. So that's why we want to create such experience to train them, so that when they are really in the cockpit, they can relate to the training very effectively. So this is also called transfer of learning or generalization. Okay, so of course it's out of the scope of this particular lecture, so I won't dive too much details. But on the other hand, are multisensory always good? Not really. I still recall at the very first beginning of this subject, I'm recording back to the very first beginning of this lecture, in this particular lecture, although we are at the very end of this semester, right? So I'm recording back to the very first beginning of the lecture. Still remember one thing, one keyword, that is adequate and comfort, right? So not all the training requires multisensory feedback. Okay, so not all the training requires multisensory feedback. And also, if you introduce multisensory feedback, and you have to pay attention to a certain kind of theory, that is cognitive load. So it's about how people can use their cognitive capabilities to process the sensory stimulations. Right? So in many cases, if you are very interested to, for example, to aircrafts, okay, and you watch some documentaries about air crash or airplane incidents, you will find that in some cases, because of the user interface design that overwhelms the pilots, so they cannot figure out what is going on with the plane. So and then the accident ended as a disaster, right? So this is about cognitive load. So in many cases, we have to optimize how we present information as well as sensory stimulations. Okay, so yeah, so this is very important. And also, multisensory XR, of course, will have some physical constraints. So for example, we have already talked about this, right? So the haptics is very difficult to do. Force feedback and tactile feedback are all very difficult to do. Although we have some off-the-shelf products, but they are not mainstream, maybe we cannot use them for our own applications, right? So these are all the information we have already discussed. So in many cases, we want to use perceptual illusions to create multisensory XR experience, right? So for example, the flight simulator is a use of perceptual illusions, right? Because we used the human brain's, I would say, weakness in distinguishing acceleration and gravity. Okay, so this is because we only use our vestibular system to feel the force, feel the change of speed, feel the change of rotation, right? So that's why we can use such kind of perceptual illusion to create a more multisensory and multimodal experience. So, and also for our just for your information and also for your reference, a perceptual illusion that we always use is about the rubber hand illusion. Yeah, if we generalize a rubber hand illusion, then we're basically talking about synchronized visual and tactile stimulation. Okay, still remember the rubber hand illusion? So the visual stimulation is very straightforward, right? So you see the fingers being brushed, although it's not your finger, right? But for the tactile, you can feel the fingers being brushed. And this time you feel it through your own fingers, right? So this is about synchronized visual tactile stimulation. I also prepared a video. So this is the research that has been published many years ago. right? So the entire experience is very close to the Pinocchio kind of illusion, right? So in this case, the user will actually use a rod to poke his own belly, right? But for the visual stimulation, it seems like he has a very large belly, right? So this is um, again, it's very close to the rubber hand illusion as well, right? So in rubber hand illusion, you see your hands being brushed and you feel it through your own hands, right? In this case, you see a virtual belly, but the belly you actually poke to is your own belly, right? Yeah, so I think this is a very encouraging kind of experience. It encourages me to do more sports, right? Okay, so that's it for the lecture 4 about visual rendering and also multi-sensory XR. So any questions? So if no questions, then we will move to the next lecture after the short break. So we will resume the lecture at 8:35. Okay, 8:35. Okay, so let's resume the lecture. So the last part of the entire subject is about application design, development process, and also followed by lecture 6, application evaluation. So it is a very important topic because I know that many of you may not have a real world experience in developing, maybe games. No need to mention about, real life XR applications. So it's very important for you to understand the process to ensure that in many cases, your your XR application is both adequate and also comfortable. So yeah, this is the ultimate goal. Still remember that, right? Yeah, so without further ado, let's have a look at what are the things we want to cover during this particular lecture. So first of all, we will talk about application domains. So this might be a new term to you. So if you are new to this term, welcome to the jungle. Okay, so this is something that I would say very rarely you will hear people talking about this in academia. But I think it is very important. It is about how your application could fit into a particular business. Okay? To be honest, after your graduation, maybe you are looking for a job. I would say in many cases, you do not have the luxury to make, for example, a VR game because the industry is not that large, right? So Valve actually did built the Half-Life Alyx, right? So it costs a lot of money. So I guess they will lose money from this project, to be honest. Yeah, but it's a very good showcase of what VR can do. So that's why I guess Valve did this. In many cases, if you do find a job in the industry, you will develop some, I would say, XR applications for non-entertainment purposes. Okay, so for example, it might be used for educational purposes. It might be used for medical usage, right? So perhaps you heard about a recent news article about using Vision Pro in operation theaters, right? So these are all medical uses of XR applications. So that's why I understand the application domain, the context where your application is going to be used is super important. Okay, so that's why we have to talk about application domains. Next, XR application development as a modeling process. We will briefly touch this because I guess many of you have already finished a software engineering course, right? So you must have already learned some of the basics, like different types of software processes, like a waterfall model, right, and agile process, right? So these are all different types of software processes. And for XR application development, it's very unique. It is very unique. It is unique simply because in many cases, your client does not understand what types of things he or she wants. Okay? So for example, if you want to build an app, a mobile app for a client, right? So the client must have already learned what is a mobile app nowadays, right? Because everyone uses a smartphone, right? So it is very easy to communicate. But for XR, it's another story because a lot of people may not have the previous experience. So it's very difficult to communicate with your client. So because of this, you may have not very clear definition or specifications of the software at the very first beginning. So you need to have an iterative process to accommodate for this particular development context. And of course, we will talk about testing and evaluation and more to be covered in lecture 6. So lecture 5 and lecture 6, they are somehow related. Okay, so if you are talking about application domains, it happens before you start working on the software, before you are starting to working on the XR application, right? And the XR application development as a modeling process is about the process you produce this particular application, right? And if we are talking about application, it may happen with an overlap to the development process. And in other cases, it may happen after you have a prototype at least, right? So these are all somehow related and also to different phases, different periods regarding the software development cycle, right? So yeah, we will talk about this so that you can at least, although we are still on university campus, but I just want to equip you with some necessary skills for you to find a job in the industry, okay? So the ultimate goals, or the questions to be answered related to XR application would be, first of all, how can the XR application contribute to the client business? As I mentioned, it can be something related to education. It may be related to medical things and health, right? So, healthcare, for example. So, but you are not an expert in education. You are not an expert in healthcare, right? How can you make sure that the XR application you developed can actually contribute to the client business in these domains, right? So this is the first question that needs to be answered by understanding, again, the application domains. The second thing would be related to the application design. So for example, what are the needed assets? How should the assets be placed? How are the supported interactions could be? Okay, so these are all some questions that need to be answered. So during, my previous experience working in the industry, it is very important for you to understand this, or at least have a picture before you pledge the resources to do it. Okay, so for example, you can imagine if we want to build something like, for example, an open world kind of game, right? Like Elden Ring, for example, the budget we are talking about is totally different from the latest Zelda series, like the Echo Wisdom, right? So the amount of resources you have to pledge would be totally different. And also this, if you are working in the industry, in many cases you work for a particular client, for example, a hospital, right, or an institute. So you have to, give them a quotation. So I developed this XR application for you, right? So I will charge you for, I don't know, maybe 500,000 Hong Kong dollars, right? So this is something that you have to, both parties have to agree on, right? Before you start working on it. If in the end you have to spend 1 million Hong Kong dollars to develop this application, then you will be in big trouble. I guess you will not be in big trouble, but your company will be in big trouble, right? And your boss will be very angry about you, right? So this is something that you have to consider. And also how the assets should be placed, what are the supported interactions, they will all impact the resources you pledge to a particular project, XR development project, right? So yeah, and also so on and so forth. You have other things related to the application design as well, like what are the multi-sensory channels you are going to provide with artificial sensory stimulations, right? So these are all some questions that you have to answer. And the last one would be, what is the optimal software development process, right? So I can see that many of you during the group project, you basically use the waterfall model, right? But in reality, even we are doing some, projects. So for example, with my PhD students and RAs, we do some projects. We don't start with, very clear design specifications, right? Still recall your software engineering course. You always start with very clear design, very clear software specifications, right? And you start doing it step by step. And in the end, you deliver the software, right? But either in research or in industry, we may not have a very clear software specification to begin with, right? So the first thing we often do with XR is to get the technology stack solved first, instead of starting making 3D models, doing UI designs, things like that, right? So this is something that is quite important, because when I first saw that you are entering phase 2, I already saw some people starting to place the scenes and also doing some 3D modeling, or some people starting working on the user interface. I was so worried, because in the end, you have to assemble all the things together, and you will have a lot of troubles to do so, right? Yeah, so I nodded. I guess you encounter such kind of problem, right? Yeah, because you haven't sorted the technological stack first, right? You have to understand, okay, if all these type of interactions can be done through, collision detection, for example, right? So you get collision detection down before you start programming any kinds of interactions. This is very natural, right? So I guess everyone knows this. So of course, you can start building very fancy scenes at the very first beginning of this project. But the problem is that the scene may not be very suitable for being used as a XR application. Maybe due to the complexity, maybe due to the rendering problems, maybe due to the particular application domain, right? So these are all the things that you have to consider. So without doing all this, you have to get the technological stack sorted out first. This is super, super important, especially if you want to integrate some of the haptic devices. It's another layer of complexity. You have to get it sorted out. Or you want to, for example, like these two are doing. They want to integrate a large language model with XR. Then you have to sort out a lot of different issues, right? So we spend like a lot of time talking about this. So it's about sorting out the technological stacks first, okay, before you pledge all the resources. So next, we will talk about application domain. So what is an application domain? An application domain is the segment of reality for which a software system is developed. Okay. So it's about reality. It's not about something virtual or something imaginary, right? So something in reality. So for example, a business model, right? So this is something that quite real for you, right? So for example, someone asks you to develop an XR application for example, educational purposes, right? You have to understand how your XR application can contribute to your client's business, right? So this is super important. In many cases in the industry, if you feel like this XR application can help your client makes a lot of money, you can ask for more money as well. Right? Yeah, this is very natural. So that's why you will find that the same amount of work pledged to building certain applications for certain application domain will cost more. I'll give you a very quick example. For example, an XR application made for medical uses, right? So you pledge, maybe it's, I don't know, maybe it costs less money to make than Half-Life Alyx, for example, but it will cost a lot of money, right, to make. So this is about the application domain. So when we talk about application domain, we always start from a certain context, right? So for example, it may restrict to the entire business, it may restrict to the organization, it may be restricted to a department or even a workspace. So it, as pointed here, application domains can either be very extensive or very limited. It depends on the problem you want to solve and how you add values to your client's business. Okay. So this is about XR application development. So this is the full picture. Okay. So I briefly mentioned about, for example, waterfall model and all different types of design things you have to consider. But to be honest, at different stage, you have different focus. You have different focus. Okay. So let me go through this diagram for you so that you can understand what are the things you have to consider. Okay. So first of all, we always start with application domain. This is super important because we want to understand your client's business in order to propose a solution. And in many cases, you can imagine your client has no knowledge regarding XR, right? So sometimes you even need to educate your client as well. But if you want to educate your client, you must understand their application domains, right? So this is very natural. And then we enter a stage into the so-called model of application domain. Okay. So what is the model of application domain? We can have a look at this. So for example, we need to consider a few things. So for example, the presentation, the handling. So what is handling? Possible interactions. What is presentation? What could be the things to be rendered? Are they purely visual? Any sound effects should be involved? or any types of haptic feedback should be involved in the final delivery, right? So this is very important. Why it is like so? Because again, it affects your budget, the resources you are going to pledge. And also why it is important, because in the next phase, you have to get the technological stack sorted out somehow, right? So you can imagine if I want to do, super realistic kind of, rendering because of the client's application domain, then maybe Unity is not a very good choice for your game engine, right? So it's much easier to achieve highly realistic kind of, rendering through the use of Unreal Engine, right? So, and also maybe in certain cases, you have to add haptic feedback. For example, your XR application will be an application for medical uses. Then maybe haptics are super important. You are developing something to train physicians using different tools to do operations, for example, right? So haptics could be extremely important. So in this case, then you have to get the technological stack sorted out in the next phase. So it's very important to come up with some handling and presentations that you can talk with your client. Okay, so how we can do it? You may ask, oh, this is super difficult to do. My client has no knowledge regarding XR. Then basically, I can't do it, right? But you can always refer to available applications. So for example, your client may not understand cyber sickness, for example, right? So cyber sickness is something new to them if they do not have any background knowledge in XR, right? So what is the best way to let them understand cyber sickness? Yeah, experience it, right? Yeah, use the roller coaster video to let them experience cyber sickness. And they suddenly realize cyber sickness is super important. Right. So we recently encountered similar issues. So for example, I'm working with a group of scholars from a school of nursing. So they have basically no knowledge regarding XR, VR. Okay. So we want to let people using wheelchairs to do some free navigations with the virtual world so that we can enhance their mental health. The idea is fantastic, but on the implementation level, there is a big catch. Because they are wheelchair users, so they are more easy to get cyber sickness. In reality, you can imagine you can go to Ocean Park to experience, for example, the roller coaster, right? But can they do that? No, right? So they are more easy to get cyber sickness and motion sickness, right? So, but we want to create the sense of free navigation within a scene. So if we do teleportation, we lose the sense of presence. If we do continuous locomotion, we will encounter, a high level of cyber sickness, right? So this is something that we have to communicate with the team and understand their clients' needs, right? So yeah, so that's why I just asked them, you can come to our lab and experience cyber sickness. It's truly a problem. Yeah, I don't have a solution yet. I don't have a solution yet, but I should make sure that my client, in this case, my collaborators, and I are on the same page. This is very important, right? Yeah. So this is about the first thing. You can show how to do this. Handling and presentation is very straightforward. You use some existing applications and you let them to experience it. Right? You want to do isomorphic kind of interactions, you show some examples. You want to do non-isomorphic interactions, you show some examples, right? Yeah, so this is how we do it. And next we progress to I would say the core part of doing the design. That is the model of the application system. So it may involve some design models, usage models, implementation models, right? So for example, the usage models could be done if you have already finished your software engineering course and understand the UML, Unified Modeling Language. Then you know that maybe I can use some use case diagrams to model the usage model, right? So how the users are supposed to interact with the system. And also, of course, if you want to do the implementation model, you can use state diagrams. We have already introduced that when we talk about the user interface design and also implementation, right? And also, of course, if you are going even more abstract into the software development part, then perhaps you can use a class diagram and also object diagram, right? So these are all different types of diagrams you can use. Yeah, but for this part, remember, we have to get the technology stack sorted out. So it is very important to understand the technology to be used. For example, the architecture and design pattern. Right? This is very high level, I would say. If you have never worked on, XR system, it's better not to do it and ask someone who is more experienced to do it. This is like the architecture designer in traditional software development. Right? You have to understand different technology stacks. You have to experience and programmed on different platforms. So, for example, the Metas platform, Oculus integration, Steam VR, Windows mixed reality, Apple Vision Pro, right? So these are all possible architecture choices and also design patterns, right? This is also very important. If you have never experienced any kinds of interactions in VR, you will make some mistakes. Okay, so for example, I still remember one group. I cannot remember where did they see maybe that area, and they did the development very, very fast at the very first beginning. But I just questioned them whether you have tried it out in VR. If you have ever tried it out in VR, you will find that your design may create a lot of um, troubles for your users, like how to do the HUD design, how to present the UI, right? So this is very difficult. I provide a lot of such kind of feedbacks to your phase 2, right? And also how to design the locomotion methods, the virtual locomotion techniques, right? Design guidelines, this is also very important, especially if you choose to design for a particular platform. Maybe you should follow the design guidelines. So for example, Apple's Vision Pro has already provided with a lot of these, design guidelines. You can refer to that. If you design for Microsoft's, HoloLens or other, Windows mixed reality applications, you should consider referring to MITK. Okay, so these are all possible design guidelines you can refer to. Technology of system basis. Okay, so very obvious, right? So different types of technological stacks related to how you deliver and also deploy your application to certain systems. And of course, system basis, right? So these are all the things that you have to consider. And next, after all these models, we have to think about the frameworks and the libraries, right? In modern day application development, especially for XR development, we do not do things from scratch, right? So for example, some of your groups may have already created a multiplayer game experience during phase 2, right? So do you start from scratch? No, right? You use some libraries like PUN, right? So these are all different ways to speed up the development process. And we do not start from the very first, the very low level kind of, programming, right? And also, if you want to harness the power of different platforms, different software development, XR development SDKs. So for example, Oculus integration, Steam VR, you should really look into the examples provided and understand the platform's the features. This is super, super, super important. Okay, a lot of the things that you want to implement has already been implemented by the hardware manufacturers, right? So you have to understand this. So that's why you have to think about frameworks and libraries. And the last one would be, developing the application system, of course, right? So as you can see, although we haven't, provide any kinds of, stakeholders on this particular diagram, right? But as you can see, in many, many cases, we have to communicate with the client back and forth and let them to experience different things, right? And also try to understand their true needs. Okay, so user is super, super important, right? So if you go to my homepage, and you will find that I'm a human-centered computing researcher, right? So why is human-centered? Well, to be honest, a lot of computing things should be human-centered, because in the end, you ask a human user to use your system, right? So if you ignore that, then basically it's meaningless to create software, right? So yeah, so this is about the different parts that I have already covered for this diagram. I will quickly skip that because I have already explained them. So this is just for your reference, and also of course you can print it out and bring it to the final examination, right? Yeah. So any questions about this? So the entire context and models for XR application development, the full picture. Any questions? Okay. So if no questions, then we move on to the next part. Not this one. Okay. So this is about how we do application modeling. So we use a particular tool that is called cooperation picture. Okay. So I don't know whether anyone has ever heard about this before. So Jerry, has you ever heard about this before? When you were working in Huawei? Something similar, right? Yeah. This is actually a very old thing. And different companies will use different ways to present this. But the core message to be delivered is very, very straightforward. That is, if we go back to the definition of application domains, it's about how you can model and document the segment of reality for business to happen. Okay, so let's have a look. So for example, this is I copied this from this paper. So this is a very good one. So it's a used car company kind of corporation picture. So you can see, of course, if you have already finished an undergraduate degree in computer science, you will immediately understand what does this mean, right? This particular icon. It means some data-driven systems, right? Very straightforward. So there are some, and of course, if you have already finished your software engineering course, you will understand what does this mean, right? So this icon is a user, is a stakeholder, right? So for example, we have human, we have software systems, but as you can see here, there are lots of different things other than users, other than software systems, other than data, right? So what is that? Well, some may be related to software systems. Some may relate it to something that's not software related, right? So for example, the communication, maybe the reservation. So for example, you can see here, the buyer can make a reservation, right? And the reservation will be taken care of by a salesman, right? But in this case, the diagram does not tell you how the buyer can make a reservation. You can imagine there are different ways. So for example, the buyer wants to buy a used car, and he may just call a salesman and say that I want to test drive this car. If it is okay, I will buy it, right? So this is one way, making a telephone call. And the second one would be filling some forms on our web page, right? So for example, I'm interested in this particular car. I want to have a test drive, and my phone number is blah, blah, blah. And then you click send, and there will be an automatic email generated, and the salesman can capture that and read it and arrange a test drive for the client, for the buyer, right? So very straightforward. And it can be other forms. It can even be, if it's 50 years ago or 100 years ago. I guess 100 years ago, people still buying used cars, right? So 100 years ago, maybe you need to send a mail, a physical mail, right, to the sales. But it doesn't matter. It doesn't matter. Remember, it's a model, is a way for us to model the application domain. And application domain is a segment of the reality. So in many cases, we do not care about details, but we care about how the information flow between different stakeholders, right? So in this case, it just tells me that, okay, so the buyer and the sales can communicate regarding information related to reservation through different means. Right? It can be a website, it can be something else, right? It doesn't matter. Okay, so this is very important. And also, there might be a man in charge of the acquisition of used cars, right? So the buyer can also be, in many cases, might be some people want to sell a used car to the company or want to exchange an old car for a newer car, right? So these are all possible. So how they communicate? In this case, they use telephones, right? But it doesn't matter. It can be a website. It can through email. It can through, fax. It can through any ways of communication, because we care about how the information will flow among these, um, different stakeholders, right? So this is about cooperation picture. So if you look at this, then different people, of course, may have different access to different software systems as well. So for example, the salesman may have access to the sales system, but they may not have access to the finance system, right? Only the accounting people may have access to the Oracle finance system, right? So this is how the information flow again among different stakeholders, right? So this is about the cooperation picture. So any questions? Any questions? Okay. So remember, the most important thing is to use this to understand how information flow between different stakeholders and between stakeholders and a system. Because why do we want to do so? We want to, based on this, application domain modeling, we want to develop something to address, in the end, an information technology communication problem, right? So that's why we have to understand how the data and also information flow. Okay, so this is very important. Okay, so this is a very quick discussion. So suppose that the used car company contact you to build a VR system for better showing potential customers their listed cars. Okay. How can the cooperation picture help with the development of a VR system as a tool for domain application modeling? Let me go back and show this picture. So you are asked to develop a VR system to better show the listed cars, right? So if you have no knowledge regarding used car, how a used car company will operate, will this be very helpful for you to understand their business? Right? Yeah. Uh-huh. Use cases, yeah. Mhm. So it gives you an insight of what kind of functionalities and the kind of presentation way customer want to see. Okay. Through the VR. Yes. Yeah. So remember, it's about the information flows, right? So we can see that for the VR application, if we develop this VR application, then basically we have to do something related to this part, right? So this is the web page. So the buyer can make an offer, and sorry, the salesman can make an offer, and then the offer can go through the web page and then reach the buyer, right? So now, because we want to replace this, so but we do not change how the information flows, right? The information still goes like salesman will receive some offers from the buyer and decide whether they can accept the offer. And the buyers will use the web page to access the condition of the used car and make offers, right? So if our VR system is supposed to better list the car, why do we want to list the car? Well, simply because we want buyers to make some offers, right? To better understand the condition of the car. Then basically we are trying to do something that is very similar to the web page in terms of how to guide the information flow between different stakeholders, right? So once you know this, it's very straightforward. And you can further ask the company, do you want something else? So for example, I can see that you still use phone calls to make such offers. Do you want me to, integrate these kind of, features into the VR application as well, right? So these are all potential offers you can, try to make to your client if you are asked to do this, system, right? So this is about application domain modeling. So any questions? Any questions? So if no questions, then we go on. We move on to see the paradox of application domain modeling. To develop our application system, we need a domain model of the application domain, right? To model the application domain, we need to know the application frame of the future application system. Right? So there is always a paradox here, right? So remember, if you look at this picture, this is the cooperation picture before we introduce any VR systems, right? So we can see it is like so. But if we want to introduce a VR system, this cooperation picture may change, right? May change. So, but can we do another application modeling before we have, confirmed all these system functions, how the information will flow? Not really, right? So for example, you propose to the client that we can do something to let the buyer, make the offers to the salesman much easier in VR, for example, right? There will be some ways to connect the buyer and the salesman through the VR system, right? Yeah, but there are just, a lot of different functions you can build to this XR system, right? You can propose it one by one. Maybe some got rejected. Some clients sometimes may tell you, maybe I want this. I'm not quite sure, right? So these are all potential issues you will encounter if you want to have a very clear cooperation picture after your system is integrated into your client's business, right? So there is always a paradox. So I would describe it like this. So although you cannot understand every detail regarding this, but at least you should have an understanding towards how the information will flow among different shareholders and between systems and shareholders. Okay, so this is the key takeaway for any cooperation pictures. It's about the information. And of course, cooperation pictures can be used for other purposes like training new employees, right? We can also do this, right? In some of the companies, in order to understand how the business will work, you show your new employees a picture like this, and they can quickly, understand, right? But what we want to do with the cooperation picture, we want to build an IT system. It's an XR application, but still is an IT system, right? So we care about how information flows, okay? Without dive into too much details regarding all different functions. So this is a very important thing, okay? Next would be usage model. Right? So yeah, I briefly talked about this, about usage model. So you can use, of course, you can use, for example, the use case diagrams to model usage, right? But for XR application systems, it's a little bit more complicated, okay, than just using use cases. Sometimes we use something like this, a low fidelity prototype. Okay. Why it is like so? Well, unlike traditional IT systems, any XR systems relies heavily on visuals, on visual cues to guide your users, right? And in many cases, as I mentioned, your users may not have the necessary background in XR. So they may be very hard to imagine what is a non-isomorphic kind of interface, how I can click this button, how I can, manipulate the window, how I can, grab a 3D thing, right? So they have all these doubts. So of course, you can use some existing applications to show them and better educate them. But another thing that you want to do is to use a prototype. Okay, it can be a low resolution prototype. It can be a high resolution prototype. So, for example, this is the prototype I make. This is called it's of course a low fidelity prototype, but in UI modeling we always call it a wireframe model. Okay, so this is a wireframe model. So why it is wireframe? Because you can see we only use rectangles, right? Some circles, some buttons, right? To model this. So it's very low resolution, and we don't have any icons. We just show icons. We just write icons here, right? So it's more like a placeholder thing. So yeah, but then you can do a high fidelity prototype. You use some ways to implement this. Maybe at the very first beginning, all these functions have not been done. So for example, this is an application that we did a few years ago to enable remote art therapy in virtual reality. Okay, so yeah, so as you can see here, the tool, maybe some of the tools, the functions for these tools have not been implemented yet, but at least we can, develop the interface and try out the interface first, right? So yeah, so this is a great example for usage modeling. If you are dealing with traditional modeling tools like use cases may not fully help you explain the usage to your client, right? So this is a great way using low fidelity and high fidelity prototypes. Design model and implementation model. Okay, so I think you should be very familiar with this. If you if you are not very familiar with this, then you will have a big trouble to find a position in in the industry, right? So you have to understand UML diagrams. Of course, you have to understand how the state diagram will be, how the sequence diagram could be, right? All these type of things in order to develop a program. Yeah, so a quick discussion. What are the software development models you have learned from the software engineering course? I mentioned about one. And also this is the one you learn first. What is that? It's called a waterfall model, right? So I guess everyone heard about waterfall model before, right? Yeah, so if we do this waterfall kind of things in an iterative way, we have the spiral model, right? And we have the agile model, for example, right? So which of the models should work the best for XR application development on paper? And which of the models did you use for phase 2 of the group project? Waterfall model is still a model, right? Maybe for many of you, you said that I didn't use any models. I just divided the work. You have to do the UI, you have to do the programming, you have to do the modeling, right? And then we combine things together within one day. Right? And then we have to submit. Oh, there are so many bugs. Forget about the sleep. Let's work together to get it down. And you go and send the professor that we have to submit it for 2 hours late. And don't give us any penalties. So of course everyone is laughing about this, right? So of course this is not a very good software process. If you can think about this, if you are developing a more complicated application for a real industry, and you have a very firm deadline with your client, and you have a budget to work with, then you are in big trouble. Yeah, so that's why at least you should implement some models first. This is the first takeaway. Even it's a very simple model, that is the waterfall model. Okay, so why waterfall model is super good in many cases, especially if you only start to do some XR programming or develop some real applications. Well, it's very controllable, right? So you do the first phase. For example, you have 4 weeks to develop an application. Maybe you spend 1 week to do the design. You spend another week to get all the technological stacks sorted out and write the software specifications in a very brief format. It may not be as complete as a real industrial standard kind of, application, but at least you can use some drawings, you can use some mind maps, right? Some very quick notes. And then you do the development for 1 week or 2, and then you do some testing to ensure that there is no, major bugs in your program. Right? This is very easy to implement, right? Yeah, so this is about some reflections regarding the software development process. And in reality, we have to use a model like this. Okay? So for example, this is an example regarding how I do XR applications for educational purposes. Okay, so it may sound a little bit complicated, but I will go through it one by one. So first of all, you start with expected learning outcomes. Okay, so because it's for educational purposes, so we care about the expected learning outcomes, whether it can help people achieve their expected learning outcomes, right? And then you do the design documents, and sometimes you have to go back and think about the expected learning outcomes again. So the design may not work, right? So in many cases, I would say this is the cheapest loop you make. If you really want to go back to the drawing board and think about it again. Okay. And next phase would be doing the prototype. And sometimes you have to go back again. Of course, it's much, more expensive, right? To go back from the prototype and to back to the drawing board and thinking about the objectives, right? And sometimes you deliver the thing and then you have to go back again. Then it will be a very big mistake. Right? It's very expensive. So this is about the XR development process. You have always to think about design, prototype, deliver something, and go back to a drawing board and then do it again. Right? So this is a more like an agile kind of development process, right? So agile, just like this, you have a quick requirements, you do it, do some prototyping, test the idea. If it is good, we continue the development. If it is not good, just forget about it and archive it, and then think about refining other aspects of the software, right? So this is about the development process. But still, the most important takeaway for you for this particular lecture is that do implement some software development process next time. Okay, so you still have some other subjects to take in the next semester, and also especially for MSc MT students, you will do the projects, right? So the projects will be quite long. You have to spend the second semester next year, starting from January and all the way to February. You will be able to select some supervisors. I will also be one of the supervisors, of course. You select the supervisors, you propose it to the supervisor, and then you work with the supervisor on the conceptual design and then the actual implementation, and also, of course, sometimes involving actual testing, right? And you have to write the report, and the entire thing will last from January all the way to July. Okay, so it's very long. It's 7 months. So it's better to implement some kinds of process, some models to help you get the work done. This is very important. Okay, this is very important. Okay, so let's stop here and we will resume the lecture next week.